Hello everyone, this is Alice. So what we're going to talk about today is functions and the different ways we can view them. You may notice that I have the screen divided up into three parts. What I hope to show by the end of this video is that each of these three sections are representing the same function in a different way. So first let's look at the graph. So this first part over on the left here. And let's just pick some number along our x-axis. So let's pick 2. And let's figure out when x equals 2, what does y equal on our line? So we start at x equals 2 and we go up. And we can see that at 2, at the point x equals 2, our y equals 5. So the point 25 exists on this line. And let's go ahead and do another point. So let's do -1. So that x equals -1, what is the y value of x equals -1 on our line? So we just go down and we can see that when x is -1, y is also -1. And so what I want to show is that this line and this equation right here contain the same information. The equation y equals x plus 1 is the equation for this line, and it contains the same information as this graph does. So what do I mean by that? So what I mean by that is that the points that are on this line represent solutions to this equation. So what do I mean by solutions? What I mean by solutions is I can take these points, I can take the x-coordinate, from any point on our graph and plug it in for x. And then I can take its y-coordinate, plug it in for y, and the equation will still be true. So let's go ahead and give that a try. So we have y equals 5. We have our 2 here. And instead of 2 times x, we're going to have 2 times 2. We're going to replace our 2 with our x. And then we're going to add the 1. We're just bringing the 1 down. So let's go ahead and simplify this equation. So we have 5 here, 3 times 2 is 4, plus 1. 4 plus 1 is 5. So we have 5 equals 5. And so that's what I mean when I say a point on this line is a solution to this equation. That when we plug in the coordinates for any point on this line for x and y, the equation will remain true. So let's pick a point that's not on this line. Let's pick, say, this point, 2, 2, and see what happens. So we're going to plug in our 2 for our x and our 2 in for our y. So we have 2 equals 2 times 2 plus 1. So we have 2 equals 4 plus 1, 2 equals 5. So this is not true. And this is sort of what I'm talking about here. Since every point on this line represents a solution to our equation y equals 2x plus 1, any point that's not on our line should not be a solution to our equation. So the fact that this isn't true makes sense. If we picked a point that was not on our line, that point does not, the information in this point, this 2, 2, is not a solution for this equation. And this is the connection between graphs of a line and equations of a line. Every point on the line represents a solution to our equation. If we took our other point, -1, -1, and plugged it into our equation, we would see that it's also a solution to our equation. So let's go ahead and do that now. If I do that. So let's take our -1 here for our y, and plug it in for y, equals 2 times our -1 for x, plus 1. 2 times -1 is -2 plus 1. -2 plus 1 is -1. And we see that -1 equals -1. And so again, we see that we take a point in our line, we plugged in its x and y coordinates for x and y in our equation, and it allowed our equation to hold true. And so this is a really important next methodological don't make in algebra. That we're shown graphs and we're shown equations, but these things are linked together. Every line that we see has an equation, and at least every linear equation we have has a graph that looks like a line. And we don't even have to look at just the integers. So let's take a look at the point x equals 1/2. And this time I'll start with our equation instead of starting with our graph. So let's just take this x and plug it into our equation. So we're going to have y equals 2 times 1/2 plus 1. 2 times 1/2 is just 1 plus 1. So 1 plus 1 is 2. So we have y equals 2. So when x equals 1/2, y equals 2. So we know that this is a solution to this equation. And since the solutions to this equation are also points on this line, we would expect the points 1/2, 2 to be on our line. And we can actually see that. So if we just go to 1/2, which is about like right here, and we go up, we see that 1/2, 2 is a point on our line. So how does this relate to our third panel over here, this chart? In algebra, you've probably been given information presented in this way. And this is just another way we can present information about a function. This chart just directly tells us what the solutions to the function are. So we can see on this chart, here. So we have this -2, 3. We can think of this as the point -2, 3. -2, -3, I'm sorry. And this -2, 3 is a point on our graph. So if we go to -2, go to -3, we see it as a point on our graph. And what we saw earlier, points in our graph are also solutions to our equation. So this -2 and this -3 here don't just represent a point on our graph, but it also represents a solution to our equation. So if we plug this -2, 3 into our equation, plug in -3 for our y, so our y value. Plug in -2 for our x values. We have 2 times -2 is -4 plus 1. We have -3 equals -3. So what this chart does is it just directly tells us basically how our function works. It says when x is -2, y is -3. When x is -1, y is -1. And directly telling us what this function is the same thing as telling us what a point on our line is or what a solution to our equation is. But you may have noticed already that we only have 5 points on this chart, and there are definitely points on this line that don't appear on this chart. So if we look at the point, -3, we went to x -3, we can see that the point, we can see that the point -3, -5 is on our line, but it's not on our chart here. We have no -3, -5. And this just shows us a limitation of displaying our function in this way. And this is also sort of shows why we want different ways to view this function. There's no way that we could write every solution on our chart. It would be too cumbersome. So let's think about what the different limitations are for each of these different ways to display a function. So let's first look at our graph. So graphs are great because they give us a visual representation of what's a broad idea of what our function is doing. We can see that our function, as our x increases, that our y increases. So what is this function? How does this function? What are the limitations of this function? So a limitation of this function is sort of like what we did here. So let's say we didn't have integers. So let's say we cared about the value. Let's say we cared about the value x equals 2.321. And so on our graph, that would be somewhere right around here. And if we look up to see what our y value is, our y value would be like somewhere in this area around here. But we don't really get an exact value for what that is. So that is the strength of our equation. With our equation, we can take any number on our x-axis, no matter if it's rational, irrational, bunch of decimals, no decimals, and figure out what its y value is. So all we have to do to figure out the y value for this x is just plug in this x value into our function. So we have 2 times 2.321 plus 1. You see that y equals 4 times 4. This equals, whoops, I just got to pull my calculator real quick. 2.321 times 2 equals 4.642. I guess that's kind of obvious now I think about it. Plus 1. So we can see that y equals 5.642. And this would have been impossible to see on our graph. Like, we couldn't have said, like, oh, this is exactly 2.321 and this is exactly 5.642. Like, we could have estimated and been like, oh, it's around like 6.3 or 6.4, and that could have been, sort of close. Probably couldn't even gotten that close, to be honest. But with our equation, we're able to see exactly what our y value is when we plug in an x value. So, what is the strength of our chart? Our chart is useful because sometimes we don't care about all the solutions to our equations. We just care about some of them. And so our chart gives us like a very straightforward view of what exactly our function is doing at certain points. I hope you enjoyed this video, and if you're interested in learning more about this topic, I will have a follow-up video that talks about how we can extract different information like slope and x and y intercepts from our function, regardless of what form it's in. Thank you for watching, and I hope to see you in my next video.